So we're going to go through the slides to do lesson 4, and then we're going to go over the lesson 4 questions. You guys are going to have a test after this. So I'll be, just make sure you're getting prepared. It's going to be an open note test. So open note means you can use any thing that we've done so far in class that's in your folders, or you can write any amount of notes that you want to take in with you, but you can't use the internet. And you can't use anybody else's notes. They have to belong to you. You're not sharing anything during the test. Okay, so for lesson 4, I'm just going to scroll down to unit 7 and open up our slides. Lesson 4 slides start on slide number 45, and that's building biomolecules. Okay, so we've most recently worked with the kits and made amino acids, and then we connected them all together. And when we were connecting your amino acids together, right, each of you made one amino acid, and then we bonded those to each other over and over again. So one amino acid lost an oxygen, which were the red circles, and a hydrogen, which were the white. One of them lost that, and the other lost a hydrogen that was connected to the nitrogen. That OH, this other H, bonded to each other to form water, H2O. And then these, where they used to be, right, where this oxygen used to be, now this carbon wants to make another bond because it only has 3. 1, 2, 3. So it wants to make another bond. This nitrogen over here will also want to make another bond because it's missing this bond with hydrogen now. So this carbon and this nitrogen will bond together, which is what we see over here. See the red pieces, the red highlights are what end up joining together. And so that's how these macromolecules, or the monomers that make up the macromolecules, that's how they bond together. We remove a water to get them to stick together. That's called a dehydration reaction. So this is actually going to be the same process for all of the 4 macromolecules. Each of them sort of go from monomers to polymers by dehydration reactions. And I know that this looks really crazy, and you won't need to remember the specifics of this. You just need to be able to recognize dehydration reactions and the other kind of reaction we're going to talk about in terms of is the molecule, are we going from one large molecule to 2 smaller molecules, or are we doing what's happening here, which is going from 2 smaller molecules, right, 2 smaller things, to 1 larger thing. And this is just a byproduct right there. Okay, I actually want to skip around here a little bit. So on this slide here, it writes out that these are called dehydration reactions, and we have a whole bunch of other examples here. So this one down here is still amino acids, how they're being joined together. It's just a different way to represent it. So we have the 2 things, the 2 monomers at the top, the 2 amino acids here. One's going to lose OH, the other will lose a hydrogen. Then that carbon will connect with that nitrogen, and also a water molecule gets formed. If we look on the top, this one's showing what happens with carbs. So we have 2 glucose monomers. One will lose its hydrogen, the other will lose its OH, its oxygen hydrogen. Those will form a water, and then these will want to bond together. So then we get maltose, where a glucose and a glucose are bonded together. So we made 2 small things into 1 larger thing, so this is a dehydration reaction. The same happens for lipids and for nucleic acids. You can see the glycerol is going to lose a hydrogen, and then this fatty acid will lose an OH. Those will go off and form a water, and then we'll have 1 fatty acid connected to this glycerol. That will need to happen 2 more times to make a triglyceride, but you get the idea. That's how we're building that triglyceride molecule, making it bigger. Okay. The opposite thing when we break things apart. So if we have two amino acids right here, they're bonded together, right? This is where they had connected. If we want to get them now to break apart, we add a water. When we add water, the OH here will bind with the carbon here, and then this hydrogen will bind with nitrogen again, and then they'll split apart. So it's exactly the opposite. The reverse steps happen in hydrolysis. So this is the other type of reaction. You need to know dehydration reactions, which build big things, and hydrolysis, which breaks big things down. So hydrolysis is the opposite. I actually find this one easier to remember because hydrolysis, hydro means water, and lysis means to break. So it's really easy for me to remember that hydrolysis reactions are when we take something larger and break it into two smaller pieces or more. But okay, so all of the macromolecules get broken down this way. When you are consuming food, right, you're going to chew it, which is like mechanical digestion, where it just breaks up big pieces into smaller pieces. But one of the first things that will happen for like actual digestion is hydrolysis, to break down these big pieces, these big molecules into smaller molecules. All right, let's look at another way to look at this. It's right here on this slide, breaking down polymers. Again, hydro, water, lysis, to break. So if you have a maltose right here, which is two glucoses bonded together, we add water, we can break them apart. Now we have two separate glucose molecules. So this would be a hydrolysis reaction. Okay, so you need to be able to label something that's showing you a big thing getting broken apart and understand that that would be hydrolysis. There's only these two to know, so though it looks really complicated, I've taught this with the other sections, and they're all doing really well with it, but I realize I'm not there with you guys today to go over this as much, but you'll have open note tests, and we're going to go through a bunch of examples in just a minute. Okay, so let me open up those examples. So if you go into, I have paper copies that I'll leave out for you guys, but just in case, the lesson 4 questions are the most recent thing, and they're at the top of the Unit 7 underneath classwork. Lesson 4 questions, I'll open that up. If you want to do it electronically, you would, just a reminder, you have to file, make a copy. That way you can edit this. Normally you guys prefer paper copies, so. All right, so I'm actually gonna make a copy so that I don't mess this up. I wanna edit my original. All right, so file, make a copy. Label the chemical reactions as either hydrolysis or dehydration reactions. I'm actually just going to delete condensation because we're going to call it dehydration reactions. I'm actually going to delete that off of the... Okay. So in number 1 here, and I'm going to do part A for each thing, and then I'm going to do part B. So in number 1, part A, we need to write either hydrolysis or dehydration. So we have this one lactose molecule. Right, it says lactose right there. And then we, when we add a water and the lactase enzyme, which breaks down lactose, we get two things, two monomers here, are a galactose and a glucose. So we went from one larger thing to two smaller things. So this would be a hydrolysis reaction. So I would write hydrolysis, or just H is fine for number 1. Okay. Number 2. Looking at these, all right, so we have the 2 amino acids here, right? We've got 1 and 1. Then we have one bigger one over here on the right. This is clearly a bigger molecule than these two. So this is going to be a dehydration reaction. We have a larger molecule. Okay. Number 3, we have one big molecule here. We add water, and now we have 2 smaller molecules. So this would be hydrolysis. Okay, it's really that simple. All right, so number 4, this one's a little trickier. It says triglyceride add lipase and water, then we have a diglyceride and 1 fatty acid. If you do that again, add lipase and water, now we have a monoglyceride and fatty acid. So clearly, this is getting smaller, right? Because we went from triglyceride to monoglyceride, so it is becoming smaller. So this is a hydrolysis reaction. That's how lipids are getting broken down using lipase, right? Something that breaks down lipids. And number 5, we have 2 molecules, and then by the end of it, we have 1 molecule and a water. So 1 large molecule, I should say, in a water. So this is going to be a dehydration reaction. I keep misspelling. It's really mistyping because I'm just like not even. There we go. Okay. Number 6. We have glycerol and a fatty acid separate from each other. And then by the end of it, we have a triglyceride, which is a glycerol with 3 fatty acids. So this definitely got bigger. So this is a dehydration reaction. And okay. All right, now we're going to go through and do part B. So I'm going to go scroll up to number 1. And part B for each question is asking if it is a carb, lipid, nucleic acid, or protein. Okay, so this is really only going to be extra credit things on your test. So don't freak out if this is really hard. This is absolutely a skill that is beyond what I would expect you to know for sure. But you may have picked up on some trends and be able to recognize some of your macromolecules. So again, perfectly happy if you can do this, but it's not an expectation. So OSE endings like glucose, lactose, galactose, fructose, cellulose, dextrose, these are all hints that this is a carb. Another hint is that it's a ring structure. And there's only carbons, hydrogens, and oxygens. Ring structure is like the pentagon or the octagon shapes. And if you guys remember, you built a glucose molecule, so you've made this with those modeling kits, and how it had a ring of carbons in the middle. Line structures are a little hard to read, but anywho. So this is a carb. So I'm just going to highlight. It's a carb. All right, let's scroll down. Hold on, I'm going to make this more obvious. I'm going to highlight it. Okay. Number 2. This has a central carbon that's bonded to another carbon that's double bonded to oxygen, and then bonded to OH, and then the other side there's nitrogen and hydrogens. These are going to be amino acids, right? So these are proteins. You guys built amino acids with our modeling kit, so you might recall these. You can see the R group or the side chain right here, which is whatever makes that amino acid unique. So I can tell that this is a protein because they're amino acids, and those are the building blocks of protein. So I'm going to do that. That's protein. All right, down here, ring structure, carbon, hydrogen, oxygen only, no other elements. So this is definitely a carb. And also hints in the name, glucose, maltose, OSE, definitely a carb. All right, number 4. Triglyceride, lipase, breaks down lipids. Right, so these are definitely a lipid. And triglyceride, you might remember, we talked about a lot when we talked about lipids, or fatty acid chains, fatty acids. So this is definitely a lipid. All right, here we have our central carbon, another carbon, double bond of oxygen. This should look familiar. These are amino acids, which means they're proteins. So I'm going to highlight protein. And then our last one, number 6, part B, fatty acid, glycerol, triglyceride. These are lipids. And because fatty acid and glycerol are the building blocks of lipids, and triglycerides are a polymer for lipids, so we might be able to recognize that. And so that's it. Like I said, this part of part B, if it's hard for you, that's totally fine. But if you are starting to pick up on some patterns, that is excellent. So now that this is done, that's pretty much all we need to do for this lesson. It's really, the focus is really on this, recognizing hydrolysis reactions versus dehydration reactions. So practice that and get your notes and stuff ready for the test. But if you look at our knowledge guide, it will kind of outline what is expected of you on the test. All right, have a great day.